Okay, so come. So what is the purpose of binomial theorem? Okay, usually what words do you see over here? Find the which term, find this term, right? But there is one special word that you need to do for this. Start with E1. Expansion, correct? We use binomial theorem to expand this for powers bigger than 3. Okay, so those people who say the power is bigger than 3, you are half true, but we are doing expansion, binomial expansion. So the simplest case of binomial theorem is you did binomial theorem when you're in Sec 2 already, technically speaking. But you did the easiest case. When n equals to 2, this becomes a square plus 2ab plus b square, correct? Correct? Then when we go up to 3, then this is when we do binomial theorem. Okay? Then we have an a cube, 3a square b plus 3ab square plus b cube. Okay? Then when we go to power of 4, when we go to a power of 4, what happens? This is a4, 6a cube b, 4. Then this is 6a square b square plus 4ab cube plus b power 4. Okay? Then if you want to go one step further, a plus b power 5, we can do this also. A power 5, 5a4b plus 10a3b square plus 10a square b cube plus 5ab power 4 plus b power 5. You can do these things very fast. Okay? You can do these things very fast with binomial theorem. So the thing about binomial theorem, the feature is when you expand this, right, you notice the terms, the first term and the last term is always a square and b square. A power 5, b power 5. This is the first and last term. The first observation. Second observation is the powers of a. First term, a square. Second term, the a power dropped by 1. This one, a also power dropped by 1, so no a. Same thing, a cube, a square, a, no a. A4, A3, A2, A1, A0. A5, 4, 3, 2, 1, 0. So the power of a decreases. The power of b increases. B0, B1, B2. B0, B1, B2, B3. B0, B1, B2, B3, B4. So the power of b increases. This is the first few observation. Then the last observation is the coefficient. 2, 3, 4, 6, 4. So 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So this forms the Pascal triangle, or this, all this coefficient, right, is your n choose r. Okay? So all these things are your n choose r. Okay? Can So the thing for this binomial theorem is that we use it to expand. But let's say if you do a plus b to the power of 10, you expand until the sky turn black, the cow go home, you haven't finished. So there is a specific tool that we use for binomial theorem. It is to look for the general term of the expansion. Okay, so the first thing that we need to find out is, so the first concept that we need to find out is, for expansion a plus b to the power of n, correct? You start off with a to the power of n, okay? And then you have your n choose 1, a and b. The power of a will drop. The power of b increases. Okay? Then you go on, n choose 2, you have a and b again. The power of a drop. The power of b increases. Do you see the pattern? Okay? And the coefficient is n choose 1, n choose r. Okay, then in the middle of this thing, because it's time consuming, in the middle of this thing, let's say if we want to look for a general term. So the general term would be n choose r, a and b, correct? So you start with n, but you minus r steps already, so it's minus r. and you start with 0, when you come to this term, you have a power r already. Okay, so this one is actually the specific general term. Okay, the general term or the r plus 1th term. Okay, example one example, a plus b square, how many terms? 3 terms, a square, 2ab, b square. A plus b cubed, we have 4 terms. So if I have n, I should have n plus 1 term. So if is n choose r, then I'm referring to r plus 1. Okay, so this is the first one. Then we go on, continue. Then we have an n choose n minus 1 of a and b. So by this time, a will drop to 1, b will drop to n minus 1, b will go up to n minus 1, plus the last term, n choose n. And then we have an a and b, correct? So a power 0, b power n. But we can rewrite this as b to the power of n, like the first term like that. Okay, so this is the expansion of the whole thing. We only need to remember the general term. Okay, we only need to remember the general term. So we need to learn how to expand. We also need to learn how to locate a specific term using this. Okay, so this is the essence of binomial theorem, to expand and to find a specific term, because the expansion will take very long. And now a and b are general a and b. So it can be 2x, can be 5 over x, or 5 over square root of x, where it gets a bit more complicated. Okay, so this is the thing. Now, I will need you to remember also a few special results. So the first one is, of course, you need to know the general term. P r plus 1, the r plus 1 term. So the format is n choose r, a and b, but n minus r and r. Okay, so this is the format for the general term. Okay, so if you are looking for a specific term in the middle, for example, term number 5, then we can do this. Then we need to also look for, need to use the n, especially when the power is unknown. So we need a few special results for the n choose something. So n choose 0 is 1, n choose 1 is n choose 2 is going to be n minus 1 over 2. Okay. On the other side, n choose n minus 2 would be n, same thing. Okay. N choose n minus 1 will be n choose n is 1. Okay, so these are the few. Okay, the more important one is this. If you want one more, I give you one more. N choose 3 is n minus 1, 3 times 2 times 1. Okay? So how do you get this? All these things is in the exit pass 6.1. So this one will be your homework to figure out how this works. Okay, I will send you the solution, you go and refer. Now, okay, find the first 4 terms when we expand this. So technically speaking, it is just this one keep repeating for the first 4 terms. So it's like computing, it's a for loop. Yeah, for 0 to n. Then you just loop and you print the answer. Okay, so how do we do this? Okay, so how to expand this, the format is like this. 3 brackets. Okay, the first bracket is your n choose r. So what is n? N is the power. So n is 6. Okay, then this is, okay, so 6, the first term is 6 choose 0. Okay, 6 choose 0. Then your a, this is your b. So a, right, the power starts with 6. 6 minus 0. Then for b, the power starts with 0. Okay? Okay, so this is the first term. Second term, let's expand. Okay, second term, same thing. 6 choose r. So 6 choose 1. Just now we always start with 0. Then we will need to start with 1. 6 choose 0, 6 choose 1. Same thing. Black color, all the same. Okay, so now 2, 6 minus 1, 3x power 1. The r is the one that's changing. Okay, next, the third term, 6 choose something. So now is 6 choose 2, power 2, then this one 6 minus 2. Do you see what's changing? Only the r is changing. Okay, so let me highlight the r over here. Only the r is changing. Okay, 6, same thing, 2 and 3x. So 6 choose 3, 6 minus 3, then power 3 over here. Okay, so 1 term, 2 term, 3 term, 4 terms. So we only need to expand up to 4 terms. There are more, but we only need to expand until here. Okay, come, calculator. Oh, actually don't need calculator. Let's simplify this first. Okay, 6 choose 0. Anything choose 0 is 1. Okay, 2 to the power of 6. I'm just going to leave it as 2 to the power of 6. This power to the 0 is also 1. So this one is times 1. Okay, so the first term is always very easy. It's always a to the power of 6. If you don't need to do this, you can jump straight to this. Okay, second one. Calculator. 6 choose 1 is 6. Based on our calculator. 2 to the power of 5. So times 2 to the power of 5. Then I need to multiply 3x over here. Sorry? This one? Here? No, this one. Oh, okay, can. Almost. Okay, can. Wow, thank you for saving me. Can. Okay, can. Thank you so much. Okay, next. Okay, 6 choose 2. What is 6 choose 2? Calculator? 15? 15, right? Then I have a 2 to the power of 4. And then this one square, be careful 3 square is 9. X square is power 4. Okay, 6 choose 3. 20. So 20 times 2 to the power of 3. Then 3 cubed, 27. X square cubed will be x power 6. Okay, then the rest we use calculator. So this one would be 2 to the power of 6 plus this. Okay, we get the coefficient out. $500. This one 2 power 6 is 64. Okay, 15 times 2 power 4 times 9. 60 what? Okay, 20 and this. 4320x power 6. Okay, so this is our answer for the first question. Yeah?
Correct if I put it in the calculator correctly.
Okay, so this is the first thing that we need to settle, the expansion. Any questions? Any questions? Does this look okay? It looks hideous at first because you never watched the video. But for those who are used to it, it's actually fast. Okay, you should be doing it fast because it's a repeated process. Okay, any questions? Okay, now one remark. So what are we doing, right, when we do the binomial expansion? This is what we call binomial expansion. So when we do binomial expansion, we are actually looking for a polynomial. Do you see a polynomial over here? Polynomial means something x squared, x cubed, x4. So this result is a polynomial. Okay, so this result will give us a polynomial. Okay, so with this, right, we actually allow us to do very good approximation of what is this. What is the value of this? It gives us a very good approximation to this if we can find the right expansion. Okay, so one application of binomial theorem is to find things like this. Okay, and to find really, really good approximations to this. Now, why do this happen is because last time we don't have calculator. Okay, it's not as easy as having a calculator in our hands to do it. So a lot of people do this by brain. And what do? Is they actually need to sub in a suitable value to find 1.01 to the power of 24. Okay, they do this by using their brains. Okay, so yeah, it's a very amazing thing last time. Okay, so now no need. Now we got calculator, we got computers to do it. Okay, question 2. Anyone still need this? Anyone still need this? Don't need, also one more thing to think of is because we are looking for polynomials, right? So your mind needs to be focused on the specific term. So the term must have some x and then some coefficient. Okay? So your job is to separate out the x's to one side and all the coefficients to one side. One more time. So your thinking is you gather all the x on one side and you gather all the coefficient on one side of the term to make things easy. Okay, so I show you in question 2. So the first 3 terms is this. We need to solve for k, we need to solve for n. So these k and the n are our constants. X is our variable. Okay, so let's try to expand. Okay, let's try to expand this thing. So 1 plus kx to the power of n. How many terms do we need to expand? We just need to expand 3 times, enough. Okay, so first one. The first one is always a to the power of n. So this is just 1 to the power of n. Okay, you can do this but waste time. So we just a to the power of n. The next one, okay, so let's do the format. So this is n, this is 1, b is kx. So let's roll. So this is 1, this is n minus 1, this is 1. Okay, next, the next term, n choose something, 1 and kx. Let's play with the power. This is 2, this is n minus 2, this is 2. Okay, do we need to expand more? Don't need. We let it be. Okay, 1 to the power of n is 1 to the power of whatever number is 1 is always 1, 0, 0. Yeah, 1. No, 0 power 0 is no answer. Okay, next one. So this one is the one which is problematic because we don't know the n, correct? We don't know the n, so this is why we need to make use of a special result. We need to make use of these 3 special results. Okay, so what is n choose 1? N choose 1 is just n. Okay, 1 to the power of whatever, 1. Okay, then next, kx to the power of 1, kx. So this is the second term. Third term, what is n choose 2? N choose 2, we don't know the n. We cannot use calculator to figure out n choose something, but we have a special result. We can make use of this. So this will be n minus 1 over 2. 1 to the power of anything is 1. Kx squared, be careful, kx squared, this becomes k squared x squared. Okay? So far so good. Let's simplify. So I have 1 plus all the coefficients together and the x. Okay, not k and s, k and x. Okay. Then all the coefficients together, so I have a k squared n minus 1 over 2 times x squared. Okay, so number x squared, number x, number x. Okay, so now we get this expansion already, and we already know that these are the values of the coefficients. So what we can do is, this kn is going to be equals to negative 50. This whole thing will be equals to 1125. Okay, so let's try and solve. So over here we have kn is equals to negative 50. And from here we have k squared n n minus 1 over 2 is equals to 1125. Okay, so let's do the easy one first. K or n, which one you like? K, okay, so I push the n away. Okay, so let me push the n away. So this is equation 1. Okay, let me put this in equation 2 and let's try to solve. Okay, so we have k square. Okay, 50 square. 2500 n minus 1. Then this one I have an n square at the bottom. Okay, let me do this. Okay, 2500 n square. Okay, from this become this. Okay, let's try to solve a little bit. This n and this can cancel. Move this over here. So 2500n minus 2500 is equals to 1125. So this is 250n. Okay, solve for n. 250n is equals to 2500. N is equals to 10. Okay, so k is equals to negative 5. But in your brain, right, you need to think in terms of the structure of the expansion. You need to think in terms of the structure of the term. So, like polynomial, 1, coefficient x, polynomial terms. So that you can compare power, you can compare terms. Okay? Okay, for 3, if you look, right, there are 3 parts. So the first one is to expand this. And expand for the first 4 terms. Okay, so if you know how to expand, right, if you really know what's going on, straight away you can write this already. Okay, if you know, straight away you can do this already. Okay, if you know the pattern, yeah, so we get the basic thing out first. So for binomial theorem, my strategy is to do it fast. We just need to get this out first. Then you put in the powers or you put in the r. Put in the r. So 0, 1, 2, 3. Okay, put in the r. Then use your calculator. This and this, use your calculator. So all this should be 1. Okay, use your calculator. This should give you 5x. Use your calculator. This should give you 10x squared. Same thing, calculator. This is 10x cubed. Okay? Same thing for b. Okay, same thing for b. Okay. Okay, very fast, right? Actually, if you repeat, it's actually very fast. Okay, so just repeat the A and B, the NC something. So you just need to roll the power. Do you see this? Okay, you see how I do this? Okay, next. let's do some simplifying first. 5 choose 0 is 1. 1 power n is 1. This one is also 1. Next one, 5 choose 1 is 1. 1 to power anything is 1. This one is negative 3x. This one, 5 choose 2 is 10 times 1 times 9x squared. Be careful of the negative. This one, 5 choose 3 is 10. 1 negative 3 cubed will be negative 27. And then you get your x cubed. Be careful. So then you do the rest. So 1 minus 15x plus 90x squared minus 270x cubed. Okay, so this is the end of part 1. Okay, part 2, hence. Part 2, hence. Find the expansion of this thing. Okay, one more time. So hence, find the expansion of this. So you got part 1 out, the expansion out. You got the part 2 expansion out. Okay, then hence, find the coefficient of x cubed. Okay, so we technically speaking, do we need to redo the whole binomial theorem over here? Don't need. We need to analyze and try to get this, break this out into these two parts. Okay, so let's try and see. We test and see whether is this the same as that. Technically, yes. Right? This one inside, you can factorize to these two forms. And after that, law of indices. Right? So the first one is this whole expression. The second one is this whole expression. So we write them out. Be patient and we copy them carefully. Sorry, I'm blocking. How many marks I put there? 2. Okay. So this one is copy this. The second one, I copy this and put here. Okay. So I didn't do anything big. I'm just copy paste. So this is how you sort. Like how do you process the Excel document? Copy paste. Put the name list. Put into group. Facile grouping. That kind of thing. Copy paste. Same thing. How to organize your data. Okay. Next. No lah, you write program to copy paste. Okay, so what are we looking for? We are looking for the coefficient of x cubed, correct? So we are looking for the x cubed term. Right? We are looking for the x cubed term. So how do we get the x cubed term? The first bracket, when we expand, right, is the first bracket multiply the second bracket, like quadratic equation like that. But which one will give us the x cubed term? So 1 times this one will give us the first x cubed term. 5x times this will give us the second x cubed term. This times this will give us the next x cubed term. This and this will give us the next x cubed term. Correct? Correct? So how do we get our x cubed term again? 1 times that. So this is minus 270x cubed. 5x times 90, so plus 450x cubed. 10 times this, so minus 150x cubed. 10 times this, so plus 10x cubed. So when you add everything together, 334. So this is 40x cubed. So the answer okay, like this. So the coefficient of the x cubed term is going to be 40. Okay, one more time. we are only aiming for the x cubed term, so we don't need to expand all 16 terms. So we just need to take this, multiply together when we expand. And then when we expand, there will be a term where these two multiply together to get the x cubed. This one and this will, when you expand, you get your x cubed. This and this, when you expand, you get your x cubed. So I'm just adding all this in to get 40x cubed, and the coefficient is 40.